This video will cover the aldol condensation. Remember that a condensation reaction is a reaction that involves the combination of two molecules with the loss of a small molecule, like water. The aldol condensation is a reaction between two ketones or aldehydes, one of which acts as the nucleophile and one of which acts as the electrophile. The carbon as nucleophile comes from an enolate ion from the ketone or aldehyde. The carbon as the electrophile is the carbonyl carbon of the ketone or aldehyde. These two ketones or aldehydes come together with the loss of water to form the aldol product. One molecule of the ketone or aldehyde acts as the nucleophile, and the other as the electrophile. The new bond is formed between the alpha carbon of the nucleophilic ketone or aldehyde and the carbonyl carbon of the electrophilic ketone or aldehyde. This reaction can occur with an acid catalyst or a base catalyst. This equilibrium typically favors the reactants, but there are ways in which we can design the experiment to push the reaction towards products. We will talk about some of the ways that this is done later. Next, let's look at the mechanisms for this process. First, we will consider the acid-catalyzed aldol condensation. In the first step of the mechanism, the carbonyl oxygen is protonated. This improves its electrophilicity. The protonated carbonyl is resonance stabilized. In the next step, the alpha carbon is deprotonated to form the enol. The enol acts as a nucleophile and reacts with a second molecule of protonated ketone, which acts as the electrophile. To produce the protonated aldol product. This protonated aldol product is also resonance stabilized. In the final step, the molecule is deprotonated to form the aldol product. Next, we will consider the base-catalyzed mechanism. The base-catalyzed mechanism goes through the enolate ion instead of the enol, but otherwise looks fairly similar to the acid-catalyzed mechanism. Remember that the main difference between these two mechanisms is that in the acid-catalyzed mechanism, our intermediates should be either neutral or positively charged. In the base-catalyzed mechanism, the intermediates should be neutral or negatively charged. In the first step, the base catalyst deprotonates the ketone to produce the enolate. This enolate anion is resonance stabilized. The enolate ion acts as a nucleophile and attacks a second molecule of ketone as the electrophile. This forms the deprotonated aldol product. In the final step, this compound is protonated to form the aldol product.